Hello, everybody, and welcome back to another episode of the DNA of Things, where we delve into the world of DNA, healthcare, and innovation. I'm your host, Dr. Jeremy Koenig. Today, we have a remarkable guest, Lisa Salberg, the founder and CEO of the Hypertrophic Cardiomyopathy Association. That's HCMA for short. Now, Lisa's work is pioneering in the field of rare diseases, which collectively affect more than 300 million people worldwide, with over 7,000 different rare diseases identified. Many people either have a rare disease or are carriers, or certainly know someone who is affected. Now, in this episode, Lisa shares her family's poignant history with hypertrophic cardiomyopathy, a genetic condition that affects 1 in 500 people. And we begin with her family's multi-generational struggle with HCM. And we move through the advancements in treatments and advocacy. And we finish with her visionary work in democratizing the development of therapeutics. Now, Lisa's dedication not only serves the rare disease community, but also contributes to a more inclusive understanding of the human genome, emphasizing that each of us is unique, yet globally connected. As you listen today, I hope you'll gain valuable insights into the importance of genetic detection, personalized medicine, and how these advancements are shaping a healthier future for all. This conversation is both informative and inspiring, and potentially changing your perspective on healthcare and genetics. Let's dive in. Lisa, welcome. It's so great to have you on the DNA of Things.
Happy to be on the DNA of Things because I got some DNA and some things.
Straight up. I love it. So a lot to explore. Innovations in heart health advocacy, which I'm sure we're going to learn about. But I love to learn from the first person, the personal journey. So Lisa Salberg, the founder and CEO of the Hypertrophic Cardiomyopathy Association. I would love to hear the personal story. Can you tell me how this journey started?
It's a complicated path, but most families are a little complicated. So for the point of my story, we have to go to pre-me, and that is 1953. I was not yet born. And my father's father had a sudden cardiac arrest on the eve of his high school graduation.
Wow.
And my father had been on a date with his girlfriend, who turned out to be my mom. And when he came home from the date, his mother was frantic. His father wasn't breathing. And my dad tried to do very early rudimentary CPR on his dad. Obviously didn't work. We would have needed a defibrillator. We would have needed a lot more tools than were available in 1953. So flash forward a few years, and my father's little brother is diagnosed with idiopathic hypertrophic subaortic stenosis in the late 60s. Before that, my sister was born in 1959 and had an atrial septal defect, which was repaired in a very early surgery about 1964. And they told her there was a little something else in there. Told my mom, there's a little something else in there, but don't worry about it. It shouldn't be a problem until she's much older. Well, at the age of 14, my sister got diagnosed with IHSS2. So my uncle's diagnosed idiopathic hypertrophic subaortic stenosis, the old name of HCM. And then my sister's diagnosed, but they don't think to look at my dad. And my dad had been an alcoholic and was self-medicating his symptoms with alcohol, and eventually came to sobriety. Super proud of him for that in the late 70s. And all of his symptoms that he was told were hypertension and anxiety and asthma turned out not to be any of that. And my dad was diagnosed with HCM in his late 50s.
Wow.
So that's the family I was born into. I am the baby. I am the fourth, but there's an 8-year break between my closest sibling and I. I was kind of born to solve problems. And one of the problems I tended to solve was my father's alcoholism, because mom needed something to trap him back at home and pull him back in. So that was me. So I was born to solve a problem. And I don't think I actually solved my father's problem, but I think I gave him a little bit more to focus on to positives in life.
Mhm.
So I was born in the late 60s. So I am a Gen Xer. And I was diagnosed with HCM in a school physical. Well, I was diagnosed with a heart murmur in a school physical and sent to a cardiologist at the ripe old age of 12.
Wow.
And it took a long time to understand my diagnosis. It took many, many years to understand the underpinning of what was happening in that room as it was happening. So it was a school physical where you walked in and all girls got down to the bra and they would do a scoliosis check on your back, and some grouchy old guy in a little round chair would put a stethoscope to your chest and listen to your heart. And that was the physical. Well, he stopped. Girls were talking in the room. He cleared the room, brought in the nurse, got very dramatic. And I'm wondering, what did I do wrong? And they started talking in code. And the code was, I think that's what she had. And they motioned out the window. Well, outside the front of the school was a memorial marker for a
Mm.
young girl who died at the age of 13. It wouldn't be until about 15 years ago that her brother contacted the HCMA and said, "Hey, I grew up in Rockaway Township, New Jersey, and my sister died. And I now have HCM too." And I put the years together. His sister died in, I think, 76, and I was diagnosed 79 or 80. So they were talking about the death of another student when they were thinking that this is what we have standing in front of us again. So they're
Mhm.
very afraid of me, afraid for me and afraid of me. So I had to go to a cardiologist before, they gave me like 3 days to get a cardiology appointment, or they were going to make me stay home from school, which I wasn't really opposed to. But we got an appointment. I met with Dr. Paul Goldfinger in Dover, New Jersey, and he confirmed that I had what runs in my family, idiopathic hypertrophic aortic stenosis, which is a mouthful for a 12-year-old. And I started my HCM journey at 12. So it was a complicated family. My aunt had also died about 10 years after my grandfather passed. She had a stroke, secondary to HCM. And my older uncle, my great uncle Tom, he ended up in heart failure, but in his early 80s. We lost dad at 73 to combination of kidney failure and heart failure. And it was 1995 when my sister died from mismanaged, poorly managed HCM. And my sister didn't have to die. There were treatments, there were options. None of them were made available to her. It ended up in a lawsuit, but not the way you think. We were patients of the National Institute of Health's HCM program. And there was fraud and misrepresentation by one actor, bad actor. And I went ahead and I was 8 months pregnant with my daughter. My sister had asked me if anything ever happens to me, promise to take care of the kids. I promised, and I did. So I had a 13-year-old, a 10-year-old, and a newborn. And I decided that the world needed to change. So I took my background in human resources and health plan administration. And I learned about this new thing called the internet. Don't know if you've heard of it. Pretty cool concept. But it was 1995, and like www was like not a known thing. Like I'd explain to people what a browser was. And I took all the information that I could gather on HCM, which was limited at the time to peer-reviewed journal articles and medical libraries, and I started to turn it into English for patients to understand their own disease. And that was the first website. It was just, what is HCM and who can care for it? So I found a couple of the people who wrote those articles, and I said, I think I want to do a thing. And they're like, what do you want to do? I'm like, I don't know. I want to build a support group or something. And that was 1995, 96. We became a 501c3 nonprofit organization. And for the first 8 years, I worked full-time job as human resource manager and health plan administrator and part-time patient advocate. All my vacation time was used to go to conferences. Didn't get much time off back in the day. And we've evolved into what we are today, which is an organization of 9 full-time staff members, about 5 contractors in different capacities, 500 volunteers, and plus minus a few there. I've worked with over 20,000 families from over 100 different countries. And we have developed the HCMA Recognized Center of Excellence Care Model, which is now recognized by the American Heart Association and the American College of Cardiology as the method of treatment and best outcomes from a high volume center. So we created those when I started that about 20 years ago. As of now, there are 50. I've got about 15 under active review and 15 already in queue to follow that. We provide intake and navigation opportunities, a patient registry, webinars, podcasts, and one-on-one peer support. And we've been doing this for 28 years now. So that's the story.
Wow.
I missed a part of the story that I always miss. And when I say that part of the story, you're going to say, how do you miss that? So my own HCM, so my niece and my nephew and my daughter are all diagnosed. So that's going future, like now and future. And I went into advanced heart failure in about 2016, and I got a heart transplant in 2017.
Wow.
And you can't even see my scar.
How do you miss that part of the story?
I don't know, but I'm always like, oh, and I did that, and then I moved on. So it's like, if I did, not something, it's not who I am.
Right. Well, I mean, it seems to me that it's kind of a, at the top of the call, we were saying, oh, well, I'm not we were talking a little bit about my background in human performance, obviously like the influence from, my own family health history, my mom being diagnosed with multiple sclerosis, and then my passion to understand health, and then also human performance. And then, looking at things through a human performance lens is, interestingly enough, not so unlike how we ought to be thinking about precision medicine. So the whole notion that we know rare disease, I mean, would we say HCM is rare? It's not technically classified as rare, is it?
Technically, it is at the moment for the following reasons. And this is where you got to start looking at things and go, what words are we using to define things? So number one, rare is currently defined as under 200,000 in active treatment for the condition.
Right.
And in the United States, we only have about 150,000 people with HCM actively getting care,
right,
which means we're woefully short of hitting all the diagnosed or potentially diagnosed individuals.
Right.
So HCM is 1 in 250, but when we start talking about DNA, my family is a myosin binding protein C mutation. That is one of the more common mutations, but still only represents about 15% of the patient population.
Right.
Myosin heavy chain is another about 15%. The troponin mutations make up another 3 to 5%. So each genetic mutation is really its own disease, as opposed to just using the big umbrella. Thick hearts are all the same. These thick hearts can also be amyloidosis, sarcoidosis, Fabry's disease. So when you think of thick hearts, you then have to think of, why is the heart thick?
Right.
Is it hypertension? Is it a genetic disorder? Is it athlete's heart? Like, why is the heart thick? And does it have negative consequences to being thick?
Right.
So we're rare, but I think the definition of rare is going to continue to evolve.
Right. Coming back to the question at hand, which was, why do you always forget or gloss over it? And I mean, it's interesting because I think it's maybe in a way you kind of had known and had processed that you were going to be up against something like this, probably, at some level, subconsciously from age 12. Is that fair to say?
It was more than subconsciously.
Okay.
In time. So I was born in 1968.
Okay.
The first heart transplant that occurred in the United States, successfully, was 1968.
Wow.
So I was born into a world that was getting ready for me.
Wow.
Which is kind of amazing. And at 12 years old, there were some things going on in the transplant community. The programs had been stopped around the country because people were dying at these ridiculous rates because we hadn't come up with cyclosporin yet.
Right.
And they didn't realize that was an anti-rejection med. So there was a lot in the news. And then there was, the attempt of the baboon heart in the child. And then there was the artificial heart that was tried and didn't work. Like, there was a lot of stuff going on. And I remember being about 13 or 14 and thinking to myself, they'll perfect transplant by the time I need it. And they did. So when I knew that was going to be my path, I was like, okay, I can do this. I had a lot of support. I had a good team. And I was sleeping in my bed on Groundhog's Day, 2017. The phone rang at 12:30 at night or in the morning. And they said, Lisa, we've got a heart, come on down. And 2 hours later, I was walking into the hospital and I was prepping for surgery and I got a heart. And 3 days later, it was handed back to me, frozen,
Wow.
because I plasticized it to keep it as a teaching tool.
So I've never spoken to anybody that's had a heart transplant before. So, I mean, what's that like psychologically preparing for that? And so going in before and then how do you feel after?
I don't know that anybody can ever really articulate in proper words unless you've actually been through the process, because there's this entire continuum. And I have to preface it by saying my sister was a donor.
Right.
So my sister gave her kidneys and her liver. So we signed the papers. And when we signed the papers for her to be a donor, I remember looking at the rest of my family and saying, remember what this feels like. I just have a sense that we're going to be on the other side of it someday.
Wow.
So I've always kind of known that was my get out of jail free card, but it ain't get out of jail free. It's get out of one jail and go to a more comfortable jail. They're all tied to the healthcare system in very unique ways. And I'm on a medication every day that keeps me alive, which is an awesome responsibility to make sure you don't ever forget your meds and that you're treating yourself well. So getting ready in advance, the most important thing I think any person should understand is we're not hoping for somebody to die.
Right.
When you're on a transplant list, you know something is going to happen to somebody that makes their life unsustainable and gives you an option to get regained health. They're not connected. There's separate things that are happening in parallel. And then it comes down to a family making a decision and saying, yes, my loved one can save somebody, and they can, I don't use this term lightly, they can become somebody's hero.
Right.
And my hero's name is Brandy.
Wow.
Her sister's name is Mandy. I don't have any other information about the family other than what I went off camera here for a minute, because I keep the letter from the donor family right next to me at all times. And it sits by my desk here so that I can, every once in a while, just reflect upon it. The letter came in on it's dated August 18th. And she said to keep writing. All I know is her name is Mandy. Her sister's name was Brandy, and she was a mom. She was 32 when she passed away. I don't know exactly where. I lost contact with the family. They changed addresses, and the organ procurement organization in their region can't find them. But if Mandy's out there listening, I'd love to chat with them anytime. And I'm incredibly grateful for my gift. And I treat Brandy as a gift every day, and I talk to her. My old heart is her, also known as the bitch who tried to kill me. And she's in a box in the other room, and this is Brandy. So if I speak of my heart, I speak of Brandy, and I will typically raise my hand to my chest to pay acknowledgement to the amazing gift I was given. Psychologically, it's a challenge to kind of take somebody else's heart into your body, somebody else's DNA, somebody else's energy, and it becomes one with you, and it takes some time to get there. But it's much better than the alternative that I had. I wouldn't be alive without a donor. I wouldn't be able to continue my work. And that would be, I think, a loss. So I'm trying to stay here until like mid-80s. That's my goal. So we'll see how that works. We'll talk then.
Yeah. Thank you so much for sharing that. There are no words. And so now I think, how many people do you know that have been through the process?
Oh, that's a tough one. So back in 2000, there was an article published about the UNOS database and how many people were transplanted for HCM. It was 1% of the total UNOS database. So there's about 3,500 transplants a year. So maybe there were 3 HCMs in 2000. Now we are about 5% of the transplant registry. So we're identified better. We're pathwayed faster into advanced heart failure management and transplant. So it is about 5 or 6% of our population. And I run 2 support groups every month for the transplant community with HCM specifically. And we get about 20 people a week or a month, coming into these programs. Some of them are pre, some of them are post, and we walk the walk together because it's one that even if you have HCM, you don't understand the transplant pathway until you show up there and you're like, wait a minute, I knew the playbook. The playbook is completely changed. And for the majority of them, it's the genes just were the genes. And these hearts were not compatible with the longevity that the rest of the body was capable of. So my mindset was always, my heart won't make it to 50, but I will.
Right.
I transplanted at 48.
Wow. So talk to me about that. So like, key innovations that you're seeing, you fast forward in your with Brandy's heart, and, you look back on everything that you learned. And, you and I have had some pretty key conversations around things like, well, we talk about precision medicine and comprehensive longitudinal data sources. But then, of course, among them, and perhaps central to them, is your DNA blueprint. You've been on the cusp of DNA and the DNA industry for 2 decades or more. I'm interested to know, okay, so I know that's probably one among them. I know one of the other things that we were talking about also is, the role for enhanced imagery interpretation. So in as much as you're comfortable sharing, where do you envision, what are you excited about in terms of key innovations? Because I suspect that some of it has to do with even just first diagnosis, like how many people are improperly diagnosed, and is that an area? And then how many people are, let's just say, suboptimally treated because we don't have the full picture. So there are 2 areas that are top of mind for me. There are probably other areas that you're aware of too. So where do you see the progress? Where do you see the path?
So I could probably give like 4 talks on the question, and I could be here for like 3 hours on that. But I'll break it down to this. Number one, when you say I've been doing it for 20 years, it makes me feel really old, but that's okay, because growing old is a privilege denied to many, right? So I'm happy to be the age that I am. So back in the late 1990s, after my sister had passed, we were involved with some early research into the genetics related to our disease in our family. And we found a private mutation in myosin binding protein C. It's in the cardiac sarcomere. It's the contractile proteins of the heart. That's where our mutation was. And we knew who had it in the family. I knew my daughter's genetic status before she showed any clinical indications of disease. She was 7 when I found out her gene status. She was 10 when we got her an implantable defibrillator. So, it's not just a DNA marker. It's a part of treatment decision-making. And the early decision that we made was, because her arrhythmias were so unusual for her age, the best protection was an implantable defibrillator, even at the age of 10, which was kind of a hardcore decision.
Yeah.
And I still, by today's data, I might have made a different decision, but by what we knew then, I needed to sleep at night and she needed to have faith that she was going to wake up in the morning.
Right.
So
just even right there, is that an upgrade compared to phys ed class scoliosis scans? Are we making progress generationally?
No, I think we've actually gone backwards generationally.
You think so? Okay. All right. Say more. Yeah.
I don't think there's enough primary care physicians in the country. I don't think we're taking advantage of the well child examinations for our children. I think we're still only bringing our kids in when we're sick. We have a legislative initiative that will hopefully, I did this in New Jersey before my transplant, and then I kind of, was a little busy for a while, but I'm back now. But what we ended up doing was we changed the law in New Jersey that every well child examination would include family heart health history questions. So we're working on legislation in Ohio and Michigan right now, and any other state that wants to jump on. We have the core language. We have a report card available for how people are how states are doing in their response to finding genetic heart disease. Like, we need to talk about this. We went to Capitol Hill to talk about this.
Right.
We had a briefing in February on Capitol Hill about the Welcome to Medicare visit to be able to ask the same family heart health history questions. We need to ask it about all people. We all have hearts. Like, how do you know what's wrong with yours or not? So we created systems in which that we can make the world a little bit more cohesive. And you can't make change by walking into a school and doing a physical on 100 kids. That help those 100 kids for that moment, but they're developing children and their hearts are going to change. And a one-time screening doesn't mean you don't have genetic disease. It means that at that moment, your heart is fine and you're not recognizing symptoms. The most common symptoms related to HCM are shortness of breath with exercise, which is often called athletically induced asthma, an innocent heart murmur, which is not so innocent, anxiety or anxiety attack, or a history of depression or mitral valve prolapse. Those are the things people are normally labeled with before they're told that they have HCM. So we want to make sure that people know about all of these potentials, and we want to make sure that children and student athletes are protected. When we find the kids who have signs and symptoms, that's fine. We can treat the child. We can take care of them. It also opens the box on what else is in that family. Mom and dad need to be screened. Aunts and uncles, grandparents. Once you find one, you open up Pandora's box and you look at the whole family. And we looked at my family. People we thought were clinically negative were genotype positive and showed disease later in life. So you've got to follow these people over time to see the manifestation of the heart, and the genetics connect. And 90+% of those with a genetic marker for HCM will at some point in their life, may not be till their 80s, develop some cardiac dysfunction. So we need to talk more about our family health histories, and we need to understand if grandma or grandpa or aunt or uncle or sibling had a pacemaker, had a stroke. Strokes and heart disease, they're connected. We don't think about it all the time. AFib leads to clot, leads to stroke, leads to brain damage, and can lead to death and disability. So if you know you have HCM and you know you're at risk for atrial fibrillation, we can protect you. If we know you're at risk for HCM and we can treat you with a defibrillator to protect you from sudden death, great. If you need the newer drugs, we'll talk about precision medicine. We've created a myosin inhibitor. We've got our first labeled indication drug. What is a myosin inhibitor? Well, that you take my genetic mutation and you break it down. For those who aren't genetic geeks or cardiac sarcomere geeks, your cardiac sarcomere is the contractile protein that makes your heart contract and relax. Myosin binding protein C mutations alter that pathway, so they make the heart work too hard. Easiest way to think about this is a rowboat. Your myosin head should dip into actin and they should move merrily down the stream. We are a sculling team with really big arms, and all oars are in and they're pushing really hard. Myosin inhibitors tell some of those oars, relax, you don't need to work so hard. And the heart starts to work more normally. But we had to figure out genetics and DNA, and we had to get into what these mutations do and what these proteins can alter to figure out how we design a medicine for this. And that medicine started to be designed all the way back in 2012.
Wow.
And we as an organization worked with the company to help design the educational materials, to help recruit patients for trials. If you told me in 1995 that I'd be working with a biotech startup to help design a new medication for hypertrophic cardiomyopathy based on genetic data, I would have laughed at you. But we've done all of that. And part of what I tried to build all those years ago was the center of excellence concept. Not only provides excellent treatment for patients, but provides silos of patients for clinical trial opportunities. And I dreamed of it 20 years ago, and then they finally showed up. So I feel like the island of misfit toys when Santa arrived.
Wow.
Like, here we go. Let's get on the train.
Okay. So a couple of things there. There's DNA testing. There's development. Let's do it this way. There's centers of excellence, and there's development of therapeutics. So on the first thing, DNA testing, what do you say to those people who are against, say, early childhood or infant DNA sequencing?
I think you got to be really careful with infant screenings.
Mm-hmm.
And there are some benefits based on certain disease types. And there are some times where I think we should maybe wait until the children are a little bit older to do those screenings. In hypertrophic cardiomyopathy, it's not really urgent that you get that genetic screening at birth.
Mm-hmm.
Once you get that genetic screening, if it's positive, it has implications to life insurance, long-term disability, and employment opportunities in certain aspects. The federal government doesn't apply to GINA. So the Genetic Information Non-Discrimination
Right.
Act
Right.
protection, but the federal government is excluded from that. So you need to just stop and think for a moment, when do I need to know about the genetic information and when is it actionable? So for
Mm-hmm.
HCM, it doesn't tend to be actionable until they're a little bit older. So infant screenings for us is something that we've never really been in favor of. However, some kids can look like they have HCM at birth because of Pompei's disease.
Mm-hmm.
Some kids can have Dannon's disease. So there are some particular mutations that might be able to be added to an infant screening that makes sense. But general HCM mutations, I would say that can wait until they're a little bit older because the information could be used against them in ways that mom and dad may not have anticipated.
Well, that's interesting because
So I'm a big
yeah.
believer.
Yeah.
I'm a big
So,
gene testing, but timing is everything.
yeah. But in this instance, timing is so what? So that they avoid discrimination?
It could be. Okay, so this dives into a slightly different area that we don't often talk about when we're talking about gene testing.
Mm-hmm.
Families with genetic diseases don't get to build generational wealth. They tend to build generational debt because of healthcare expenses.
Mm-hmm.
So you need to take a moment and think about the financial planning of a family and
Mm-hmm.
ensuring that everybody is protected. So a lot of our families have young adults who have died suddenly or unexpectedly, and they were never able to get life insurance. So then the children are kind of two steps behind because they don't have basic needs supported financially.
Got
So
it.
you just need to take a moment and evaluate the whole picture of the family history.
Mm-hmm.
And I am a huge supporter of gene testing. I think there's so much to be learned and we can be proactive, but we also need a regulatory language to keep up with us that there should be
Mm-hmm.
an alternative pathway for reasonably priced basic life insurance for some families,
Gotcha. Gotcha.
long-term insurance. Yeah.
Got it. Got it. Okay.
Even a lot.
Yeah. Yeah. Well, you've always been on the kind of the innovative side of things because I think weren't you in the early discussions with 23andMe in terms of it was HCM or Parkinson's, and I guess they went the Parkinson's route.
So I did get some early interest
Mm-hmm.
from one of the original founders of 23andMe, and they came and said, "Hey, we got this idea." And I'm like, "Is society ready for this yet?" This was a long
Mm-hmm.
time ago. This is pre-public launch, right?
Right.
So
So it's
I
like
looked
2004, 2005 would have been, right?
around that time, yes, because I remember I actually met with one of the founders. I brought her up and I introduced her to Dr. Christine Seidman at the Harvard Genetics Lab, the Seidman Laboratory. And I said, I don't know that society's ready for this yet.
Mm-hmm.
Should HCM be the beta test? And maybe we should have, maybe we shouldn't have. I don't know what the right answer was, but at the time, it didn't feel like we were really ready and that we had the infrastructure in place to support families. 2008, we passed the Genetic Information Non-Discrimination Act. Just talked to Sharon Terry this morning. We pounded fists in Washington trying to change laws, and we got it in 2008. But 23andMe was, just a concept at that time. I liked what they were doing. I know my ancestry. I am 58% Scandinavian, proven by my DNA, and a child of Charlemagne. So to my 23 million cousins out there, what's up? But there's some fun stuff to learn about yourself and DNA, but there's also some real considerations that people need to make before they go ahead and get that testing done. And genetic counselors can play a role in that. Advocacy groups can play a role in that. But I do believe that we as society need to open up our eyes and say, A genetic test is just like any other test you have. Whether you scan your body, you know information about it. Whether you
Right.
do a blood test, just a regular old CBC, you learn a lot about yourself. And
Hmm.
information from that can be used for and against you in a lot of different ways. So you need to stop and think about what you're doing and why, and be a good consumer of healthcare product.
Hmm. Which is hard to do when you're faced with a life-threatening injury or life-threatening injury, life-threatening disease. It's like even though, for example, I've been you know poking around in the DNA space for over a quarter of a century now. When I look at my daughter's DNA, I'm like, yeah, I can look at it and I can interpret it, but I still go to a counselor because you need that kind of outside perspective from somebody who doesn't have the emotional bias that you do. So
We
yeah, very, very, very interesting times that we're living in. And so, you talk about scans, you talk about health records, and again, we're talking about the development of therapeutics, which you've seen some benefits from recently, and I believe you're potentially pioneering the future of that. So what's that like? What's it like to move towards a new standard of health record documentation? Because I think about my own health records, and they're kind of everywhere, all over the place. I don't remember half the things that I've done, and every time I go into, say, physio clinic or whatever, getting any kind of treatment, and you're given these multitude of forms, which I'm not sure that I've ever entered the right answers twice, and then, by the way, every time I do have to fill out those forms, it kind of brings up the old emotional scars of, say, oh yeah, I remember I had that appendicitis or that surgery. And so anyway, so all the emotional stuff aside, just having the record as a single source of truth, that longitudinal data, and then having multiple individuals, let's say, with different versions of the disease compared to super healthy normal controls. Like, what does that mean for the future development of therapeutics? So what does that mean in terms of what kinds of drugs might we develop? What kinds of treatments that actually might not require drugs? What might be revealed, and how, if at all, does this benefit the next generation, or potentially this generation?
I think it's this generation is going to be the beneficiary.
Nice.
Meaning, I think anybody under the age of 75 will see meaningful improvement in their ability to access their health information in a meaningful way.
Mm-hmm.
Meaningful, that's the critical word here, right? So I can put a lot of data together and say, look at all my data. Yay, I have all this data. Health insurance companies are currently making 1/3 of their revenue from selling your data. And that's just kind of like a gut punch to patients, like, it's mine and you're
Right.
selling your own stuff. So
Yeah.
imagine if somebody came into your house and decided that I'm going to sell the dining room chairs.
Mm-hmm.
Like, I need my dining room chairs. So they're
Mm-hmm.
selling your data. And they're saying, well, you signed these papers authorizing us to have your health information, and we're keeping your healthcare costs down by selling your data. It's not exactly transparent and honest.
Mm-hmm.
So I see a different future. And yes, I joined the health industry in 1988 by being a health plan administrator for a self-insured insurance plan for my company at the time. And I came in with that lens, but I came in as being a child diagnosed with an uncommon disorder and told that I could die suddenly and unexpectedly at any moment. So I wanted good healthcare for myself, but I also wanted to make sure people had good healthcare access for themselves because they didn't know what problems they were going to have. I should mention that shortly after I hit adulthood, at the ripe old age of 21, I ended up with a nasty complication called endocarditis, which is a bacterial infection inside of your heart, which
Wow.
broke off a few clots, and I've had multiple strokes as a result. So from a very early age, I had negative consequences of my disease, and I needed to make sure we had good coverage and that everything was as it should be as healthcare started to shift and evolve, and PBMs just came into being, and paid provider services and PPOs versus HMOs. We had the battle on that. We had the battle for, a nationalized healthcare system, which we've talked about multiple times and we keep failing. even though 50% of the US population is insured by socialized medicine, but we don't want to tell people who have socialized medicine that they have socialized medicine, but I digress. We need to be talking about access, and we need to be talking about organizing our data. Now, we've made some great steps. Electronic medical records help tremendously. Getting access to that data has been made easier through a lot of pieces of legislation that you, the patient, now have control over your data. What does that mean? It's evolving. I imagine a day for those who are in my community, so the thick-hearted community, that we will be the heart health home for those families to store their data and to choose whether or not they wish to share that data with researchers, with academic researchers, with pharma companies, with device companies, with gene therapy companies. And if we can take the entire story, the genetic information coupled with the clinical information, coupled with the emotional burden and data on emotional well-being, financial well-being, wearable data, what am I doing every day? What am I capable of doing? And how have I changed? Imagine if you could put all that information in one place and then decide, I want to give it to Dr. X for a second opinion. And you send a nice little capsule of your information to Dr. X. You schedule a virtual second opinion. You can speak to them at any time at your convenience, and you can get expert care no matter where you are. This is my goal. I don't want patients with HCM who don't happen to live in the Northeast of the United States where we have lots of centers. Maybe they live in a remote region of, Wyoming, and they have HCM. They should be able to speak to knowledgeable physicians and have their data reviewed by experts no matter where they are. But how do you facilitate that? What is the system that you put around it? And how do you capture the data and have patients eventually be able to answer the question, what happens to people like me? What am I looking at? Now, I've been doing this for a long time. I've worked with over 20,000 families, which is about 40,000 to 50,000 affected individuals. I'm a novice. I'm an expert in a very unique space, and I'm a patient advocate expert. I'm not a clinician. I'm not a nurse practitioner, although I have one on staff. It's not my job to say, do this and do that, but we can teach people. Well, your left atrium is enlarged. Your outflow tract gradient is over 50 millimeters of mercury, normal 0. We see your mitral valve is adversely affected. It's getting a bit wonky in itself, whether you've got +1, +2 regurg, but the mitral valve isn't acting right. We know that if you keep doing this, that you're going to go into heart failure and you're going to have some really bad consequences. But if we treat it, we can alter your course. And there's a number of different ways to treat it. Which way is right for you are going to vary based on your individual anatomy. Some genetic information might come into play, and what experience that you're having in terms of your symptoms. But no two people have the same exact answer. So to understand as a patient, and how the hell do you understand that when somebody just threw this name at you that, oh, by the way, you have this rare heart disease and, oh, it could kill you at any moment. Oh, shit, what do I do? So you try to learn about your disease, and we try to make that very tactile and very real. And we talk to people. We don't put you through a bot. There's actually humans here to talk to you. But you need the human, you need the data, and then we need to get better with the data. So what's coming and how are we going to get there? AI technology for EKG and echo reads is going to come into play. We're going to be better at reading the information that's in front of us because computers are going to help us. We still need to program the computers and tweak the computers to give the right information. And I know a lot of great people who are working on those projects, whether it be EKG, whether it be your echocardiogram. I think we can get better with AI, but AI is not going to stand alone on this. You're going to need the experts. What else can we do? Well, we've developed a whole new class of medications. There's going to be more coming in the cardioenergetic space. So we think about weak hearts a lot and how to make them stronger. We're the opposite problem. Our hearts are too strong. We got to make them more efficient, which means to lighten them up a little bit and take away some of that pressure and vigorous pumping. So there's drugs that can actually calm the heart, but not too much because that's bad. But it's dangerous. And that's why the drug that's on market right now is under what's called a REMS program. So a risk evaluation and mitigation system is on the label from the FDA that only certain doctors can do this and you need certain surveillance. Because these hearts, if you relax them too much, then they get too weak and then they fail. So we're learning all of that. And we've got maybe 8,000 prescriptions on a labeled indication for the first drug to market. The second myosin inhibitor, I'm going to Lisbon this weekend to see the data presented. I think it'll be coming soon. I'm expecting really good information come Monday. So stay tuned to the HCMA for that. So more drugs are coming. And what happens after drug therapy? Genetic therapy. We've already dosed 2 patients, maybe 3, with a novel AAV9 correction delivery of protein to a defective mechanism. And then after we get this AAV9, there's another therapy coming down the pike that's got a similar concept, but slightly different. And then there's gene editing that's going to come into play, which we haven't gotten there yet. But all of these things are evolving, and they're all based around true personalized medicine. What is your gene? How do we alter it?
Wow. So, okay, genes, data, health data. You also talk about the center of excellence. How do the centers of excellence fit into this?
Oh, well, they're kind of the hub and spoke of the care for an HCM patient.
Right.
And many of them are our partners. And as patients now own their own medical data, the patients will soon be able to trigger that our system can pull certain data from their file so that if they are currently living in the Northeast but want to go, to the West Coast, that they can have one place where all their data is stored and share it with their new doctors, or if they're on vacation, they have their data in one place, or when they're not here anymore, they can give it to their family members. So the center of excellence is where you get the highest quality data about your heart. And there are partners in this entire enterprise. And we are trying to evolve our community into being true participants in comparative effectiveness research, because we want patients to be able to make the decisions. What do we do in my case? Your case is different. Your goals are different. My goals are different. How do I get there? So you need that center of excellence partner to help you make those clinical decisions. And you need to know what the options are. Let's go back to my sister for a moment. My sister was coerced into a clinical trial for a pacemaker for HCM. She was told if she did the trial, that additional care would be given to her daughter.
Wow.
I was told that if I consented to allowing my 3-month-old daughter to have a cardiac catheterization, that I would be provided with an implantable defibrillator. That's not the way clinical research is supposed to happen.
Wow.
That's not the way a trial is supposed to be conducted, and there should never be coercion. If you go back in the records and you look, when did we make a lot of changes to clinical trial protocols and rules and regs? A lot of it happened in 1996. Why? Because we had brought the failures of one bad guy to the attention of the NIH, and they were like, all right, we need new policies. Wow. And sometimes it's one bad guy that makes a lot of trouble for a lot of other people, and that's what happened in this case. So bad guy has faded into the distance, and we're still here with a problem that needs to be solved. So we developed the Centers of Excellence to be able to be a multidisciplinary approach to handling this complex patient population and to providing the most ethical clinical trial establishments possible. But patients need to know what their options are. And everybody has biases. Surgeons like surgery, interventionalists like interventions, imaging likes you just look at all the images, and heart failure people like to medicate. So how do you put them all together? You make them a multidisciplinary team. They have team consults, and they share the information collectively. So there also have been spokes for the local cardiologists in the community to get extra support for complicated management cases.
Got it. Well, and you actually pointed to an additional, force multiplying power there, which is the power of family data. So the pedigree analysis alongside the individual health information, because that provides orders of magnitude of improved predictability. I mean, I think we believe we have the Mormon population to thank for, some of the early breast cancer developments, because they kept such great pedigrees. I think that's Ancestry DNA's big move. At least that's what I thought in terms of their health move, which they don't seem to be going on. But regardless, it seems like, you've done that or are doing that with your community. I could probably listen to you for 3 more hours, and I know I'm going to in the future, but I want to take a little bit of a turn into, some perspectival shifts that you might have had, from childhood to where you are now, where you see the future, given everything that we've talked through. What kind of legacy, are you looking to leave? And, generally, so how has this changed you? And really, like, what advice would you give others looking to, enter and follow your footsteps in health advocacy, whether that's for-profit or not-for-profit leadership?
So, you've hit a period in your life when people say, what do you want your legacy to be? And I am unabashedly, my age, and I am perfectly fine with that. I'm really happy to still be alive. I have a unique perspective on the entire evolution of the United States healthcare system
Mm-hmm.
from the inside and the outside. And it is broken. It's a broken system in desperate need of our attention, and in less need of having more individuals come to the space to figure out how they can churn money out of it. Our priorities are all screwed up. And I think we all need to stop and think. And when I say all, the stakeholders are policymakers, physicians, payer services, so all of the insurance companies. The patient tends to come in towards the end of this process, and we're the afterthought. There's a lot of money being wasted on things that are supposed to make things more efficient, but we're losing track of that. So I've been acutely aware of absolute missed opportunities, negative consequences of healthcare interaction, because people just thought they should do something because doing nothing just didn't bring in any revenue. A case was brought to my attention where, using newfangled technology, I'm not going to say which one, they were able to identify somebody who has HCM. Had they used the old-fashioned way, they would have gotten there too, but they used a newfangled way of doing it, and the person immediately went off to get a therapy that it turns out that they didn't actually need, but has a ticket price of about $180,000 that they didn't really have to do, and it has downstream consequences and risks. So people need to slow down, look at the data, maybe get more second opinions, maybe do virtual second opinions. We need to lean in more to virtual medicine, and we can do better. So I think we need to stop thinking of how to spend money and start thinking about how to be good consumers of healthcare product and how to be good deliverers of healthcare. So we need to be smarter, not more expensive all the time. So I've watched the evolution go from paper files to computers to electronic medical records to wearable data. And, we've all evolved together. I grew up without computers and with rotary dial phones and 13 channels on TV. We have data overload right now, and we have opinion overload. And scientifically, I think we've not done a good job in this country preparing our children to be good analyzers of health information. I'd like to go back to the U.S. education system and require certain educational elements be required in high school, because everybody's going to be a patient someday. Right. How do you be treated? How do you make decisions? Right. How do you think about what you want, what you need, what your goals are, what you're willing to do? And it may change. Personal experience. When the newest technology in pacemakers came out a number of years ago, I remember looking at these leadless pacemakers and thinking that is the stupidest idea I've ever heard of. Why would you want to put something permanent inside of your heart? That doesn't sound like a good idea. Flash forward to this fall or this spring, my transplanted heart went into intermittent heart block. And now I've had pacemakers and defibrillators since I'm 23 years old. I am kind of messed up in all of my access points on my left side where the device normally goes. So now I'm looking at my options and I'm looking at leadless pacemakers. And I'm the girl who said 15 years ago, that's stupid technology. Well, it wasn't smart for me at that time, but it was right for somebody. And I ended up being that somebody. So I'm really glad that leadless pacemakers were invented because
Right.
I needed one. So you may not have the perspective at the moment that this is something useful because you don't need it or you don't understand it. People need to have an understanding of the evolution of their decision making along with science. I lost a very dear friend. Her name was Pam. She needed a heart transplant. She did not have HCM. She was my former assistant in my HR world. And she had a single ventricle defect at birth and had a Fontan procedure. She needed a transplant. She didn't want one. She didn't want one. She didn't want one until she needed one. And then she wanted one and she couldn't have one. So we need to think about what we expect from the healthcare system by what we give them to work with. We have to take responsibility for our own wellness, and we have to integrate that into our decision-making and our communication and how we want to interact with healthcare. In a day when we have gene therapy coming, in a day where, it was sci-fi a few years ago to think about, what if I could fix everything that's wrong with me? Well, I think we're going to be able to do that. And gene editing and gene therapies can take away the bads and leave us with betters. And it's not science fiction. It's here. And we need to start talking about it because the price tags on some of these things are going to seem quite extreme. And they're not, because you have to look at health economics, not only from the individual point of view, but with genetic diseases as a family. So let's take hypertrophic cardiomyopathy. I can stop HCM by having my child through a process called preimplantation genetic diagnostics. That is done through IVF, genetic testing of the embryo, and implantation of embryos that are not affected by the genetic mutation. That's how you can stop this. However, what if the child is, a Friday night and a date night and, the biological creation of a human that carries the mutation? Well, after birth, there might be an opportunity to alter that genetic presentation by doing gene therapy, but it does not affect the offspring because egg and sperm do not take up this fraction. Right. So we all have to start thinking about what it costs to treat disease versus cure disease. If we could cure, the price tags are going to be $1, $2, $3 million. That's a lot of money. How much money do you think my life has cost the healthcare system? Endocarditis, stroke, 5 implantable devices, 6 now, a transplant, heart failure management, milrinone therapy, IV, PICC lines, all of it. I am in the multi-million-dollar space. Now imagine you could have cured me for $3 million when I was 12. Is gene therapy right for everybody? No, not every family needs it. But families who have bad outcomes from complicated disease, I think there's going to be a wonderful opportunity for them. And I'm truly excited to be living in this time.
Wow. Well, guys, Lisa, you are a pioneer among pioneers. And listen, I know that you founded and you're running a not-for-profit and you're always looking for like-minded individuals who want to join your mission. So what is the best way for people to contact you, to reach you, to join up with you?
All my data geeks can probably find me on LinkedIn, but our website is the number 4hcm.org. You can contact our office. We like to collaborate with people. We have wonderful partners all over the world. We're building out international outreach for HCM patients and families worldwide. We're working with programs in Brazil right now, in Scandinavia, Australia, and beyond. We are looking for international solutions. We're mostly US based, but we have this international outreach. We want to work with everybody who's interested in thick hearts, whether it's HCM, amyloid, Fabry's, HFpEF. We are interested in the big-hearted community. We provide resources and we look for innovative solutions. So if you're a data person, if you want to work big data, if you are interested in innovative approaches to genetic diseases, just call us up.
Amazing. Lisa, from my heart to yours, thank you so much. It's been an absolute pleasure. Definitely want to keep in touch, have you back on the show. I've learned so much, and I'm sure everybody listening has too. So thank you.
Thank you for the opportunity to speak to your audience, and I hope that I hear from you.
Thank you for joining us on this episode of The DNA of Things. Lisa Salberg's story, as we've learned, is not just about her family's battle with HCM. It's a testament to the power of advocacy and innovation in the field of rare diseases. With approximately 300 million people affected by rare diseases worldwide, Lisa's work is crucial. As we've learned, there are more than 7,000 different rare diseases, and while not all of us may be expressing them, there's a good chance that we're each carriers. So her efforts in the realm of rare disease and genetic detection and personalized medicine are truly paving the way for more inclusive and effective treatments, benefiting the global community. Today, we've explored the importance of understanding rare diseases, the impact of genetic research, and the future of therapeutics. Lisa's vision of democratizing healthcare and making advanced treatments accessible to all underscores a fundamental truth. While each of us is unique, we are all part of this global tapestry, this cosmopolitan metagenome, if you will. Her dedication reminds us that advancements in healthcare can bridge the gap between individual uniqueness and collective well-being. I hope Lisa's insights have not only informed you, but also inspired you to think differently about healthcare and the human genome, and to make you feel truly empowered. I hope you found this episode valuable. Please share it with your friends, family, and community. Let's spread the awareness and support the ongoing efforts to improve healthcare for everyone. Until next time, stay curious and continue exploring the DNA of things that make us each who we are.